Now let's talk about a place in OSI model where the network engineers start caring of. The transport layer. Transport layer is one of the fewest layer that is exactly same in OSI model and TCP/IP model. So in the last chapter, we were talking about the first three layer in OSI model. Those are the application layer, presentation layer, and the session layer, which is totally controlled by the operating system and the application itself. The network engineer doesn't have any control over the traffic through those layers. The transport layer is the first layer where there is an involvement from a network engineer can possible. So in this chapter, we are going to discuss about the transport layer. Welcome to CCNA200-301, Implementing and Administering Cisco Solutions, Chapter number 20, Transport Layer. Learn CCNA with iRush Academy. I have placed the complete CCNA playlist at the top right corner of the video information bar. In this chapter, we will discuss about transport layer functions in a network, multiple protocols used in transport layer, TCP and UDP protocols, the port number, well-known ports. Welcome to iRush Academy, an unlimited learning platform to enhance your skills. Subscribe to the channel for more videos. Welcome to the transport layer. In the last chapter, we have talked about the topmost three layers, which is application, presentation, and session layer of an OSI model. We discussed about its functionality in a network communication, and this chapter we are going to concentrate on transport layer. As we mentioned in the introduction, the transport layer is the first layer from the top of an OSI model where a network engineer is actually dealing with. Because in the case of topmost three layer, that is the application, presentation, and session, there is no direct involvement from a network engineer. It is managed by the operating system or the application itself. So what is the function of a transport layer in a network communication? The transport layer manages the protocols that used in the communication. So in the OSI model, the first layer from the top is the application layer. And its function is it provides the services directly to the user application. Then the next layer is the presentation layer. And presentation layer translates the data between the application layer and the network format. It converts the data from the application layer into a generic format so that the other host can understand. Then the third one is the session layer. Session layer manages the session between the application on different hosts. It start and end the session. So these are the function of three topmost layer in the OSI model. So here the application is ready to send the data. Presentation layer, it's already converted that data into a generic format, and session layer already started the session. Now what is next? Here is the action of transport layer coming in. The transport layer manages the protocol that is used for the network communication. There are a set of well-defined protocols we used in the network communication, and the transport layer manages those protocols. The protocols used in the transport layer for the network communication is called TCP/IP. What is this TCP/IP? TCP/IP stands for Transmission Control Protocol or the Internet Protocol. Actually, this is not a single protocol. This is a group of protocols that used for multiple purpose. To explain this concept, let's go to the Microsoft Office. Everybody know what is that Microsoft Office? It's an office package which is contain multiple applications like Excel, Word, PowerPoint, Microsoft Note, Microsoft Outlook, and Access. Each of these application is used for multiple purpose. For example, Microsoft Word is using for the document creation. Microsoft Excel is using for the spreadsheet. PowerPoint is using for presentation. OneNote is using to create a note. And Microsoft Outlook is using for the email communication. And Access is using for the database. So the Microsoft Office itself contains multiple applications, and each application using for multiple purpose. Normally nobody say that I am using Microsoft Office to create a document or to create a presentation. Instead, they say I am using Microsoft Word to create the document. I am using Microsoft Excel to create the spreadsheet, or I am using the Microsoft PowerPoint to create the presentation. Actually, all of this application is coming under the Microsoft Office package, but it has individual purposes. So this is the same concept of TCP/IP. TCP/IP is a package or a group of protocol which include single protocols using for the multiple purpose. Some of the examples are TCP, the transmission control protocol, and another protocol is UDP, user datagram protocol. So in the same way, there are multiple protocols called ICMP, HTTP, DHCP, ARP, SNMP, DNS, FTP, SMTP, OSPF, IMAP. These are just some example, and there are more and more protocols available in the TCP/IP. So basically saying TCP/IP is a group of protocol, and each protocol in it is using for different purpose. So there are two major protocol types are using in TCP/IP, and they are TCP and UDP. TCP stands for Transmission Control Protocol and UDP stands for User Datagram Protocol. Now let's discuss about the TCP and UDP. First we are going to discuss about the TCP, and TCP stands for Transmission Control Protocol. TCP is very reliable protocol. TCP is slow in action. And when we say the TCP is slow in action, it doesn't mean that actually it is slow. It is slower than the UDP. Now let's discuss how the TCP functions in a network. To understand that, we need to discuss about the three-way handshake. So three-way handshake is a method of communication used by the TCP for the network communication. TCP is considered as a reliable protocol because of this three-way handshake. To explain the three-way handshake, we have a client computer here and a server here. Let's talk about the communication between this client and the server. The client machine is going to send the data to the server, so it sends a sync command to the server. This sync command is nothing. Here I have sent some data. Did you receive it? If you receive, just acknowledge that. So when the server receives the data, it sends the response back to the client, which include a sync and its acknowledgement. So here the sync is the response from the server, and the acknowledgement means it's sending an acknowledgement signal, yes, I have received the data. So when the client receives that acknowledgement, it sends back another acknowledgement to the server back. It is saying, okay, I received your response and I acknowledge that. So server received that acknowledgement and it can understand, okay, the client received my response. This is the three-way handshake for every communication happening between two devices. It may be two hosts or one server, client or anything. So what will happen when this client didn't receive this acknowledgement from the server? So the client will think that the data which it has sent to the server, he didn't receive it. That's why it is not receiving the acknowledgement back. So what the client will do, it will resend the data again to the server till it receives the response from the server. In the same way, when the server sends the response back to the client, if it didn't receive this acknowledgement back, it will think that the response is not received by the client and it will resend it again. So in this way of communication, both the client and the server make sure that it sends the acknowledgement for each data it receives so that both can understand the data is received by the other party. Hence, there is a reliable connection. So that's why the TCP is called a reliable protocol. Now let's talk about the UDP. UDP stands for User Datagram Protocol. UDP is unreliable protocol. So when we talk about the TCP, we said TCP is a very reliable protocol because it is using three-way handshake method for the network communication. But the UDP is a unreliable protocol. They are mainly using for the real-time communication. And UDP is very fast in action. Since UDP is mainly using for the real-time communication, there is no concept of three-way handshake or any other acknowledgement process that is happening in TCP. So that's why UDP is very faster than the TCP. So what are the functions of UDP, where the UDP protocols are mainly using? So the UDP protocols are mainly using in the voice over IP, the telephone communication over the IP address. And they are mainly using in online game streaming. You might be played aloud the online game with your friends or as a group, like when you press any key in your keyboard, the character is walking or he's shooting or he's jumping, etc. So the protocol used in online game streaming is mainly UDP. Then another purpose is UDP is using for the video streaming. So when you stream a video over the internet, it may be an event or a movie. UDP is the protocol using in that purpose. Another example is audio conferencing. When you have a telephone communication, audio conferencing over the internet, UDP is the protocol used in that concept. So we know that the UDP is mainly using in real-time communication, where the acknowledgement of the data is not required or it is not relevant. So what are those kind of communication? We already said it's a voice over IP or audio conference, online streaming or movie streaming, etc. We all know the famous TV series Breaking Bad. You might have watched in the Netflix or any other platform. So as you see in the screen, the character Walter White is making a telephone call with the lawyer Saul Goodman. And during this communication, these are the data it is sending from Walter White location to the Saul Goodman. And there are 5 packets of data. The packet 1 stands for hi, packet 2 stands for how, packet 3 stands for R, packet 4 stands for you, and packet 5 stands for man. So this message is, hi, how are you, man? That is a message the Walter White want to send to the Saul Goodman. So this is a real-time communication. So each packet named 1, 2, 3, 4, 5, it has to send to the Saul Goodman in the proper order as it is. For example, he must receive the packet number 1 first, then 2 second, 3 third, 4 fourth, and 5 on 5th. If any packet is missing in between, the message that received by the Saul Goodman will be wrong. And resending that packet again, it is not relevant. It doesn't make any sense. For example, the Walter White is sending the message like, hi, how are you, man? So what if these packets are not received properly at the end? Here imagine the Saul Goodman receive only the packet number 1, then packet number 3 as packet 2 and packet number 5 as packet 3. The packet number 2nd and packet number 4 are missing. So what if we try to resend that data again to Saul Goodman, because he already received hi, are, man. So he received the message hi, are, man. Now same like TCP, if you are resending the packet number 2 and 4 again, what will happen? Saul Goodman receive the packet number 2 as 4th packet, which is how. Then he will receive the 4th packet as packet number 5 at his end, that is you. Now when he get this message, when he read this message, it is hi, are, man, how you. It doesn't make any sense, because the recipient never get the proper message in real-time communication by resending the data. So that's why in real-time communication, we never use resending the data, same like TCP IP, because it is not relevant when the communication pass and reach to the next level. Now let's come back to the electronic shop where I wanted to purchase a home theater system which cost $100. Here the client machine is the cash register and it is sending a sale order to the server for $100. Now here, how can we make sure that the sales order for $100 it has sent to the sales application in that server? Maybe this server is using for multiple purpose. Maybe there is a website hosted in this server, so the server is functioning as a web server, or it may be using as an FTP server. FTP is running in this server, or maybe there is an online gaming platform running in this server. How do we make sure that the sales report sent to the proper application in the server? What if this request is hitting at the website, Or what is if this request is hitting at the FTP? So how do we make sure that our communication is properly hitting at the right destination service? Here is the concept of port number. The port number is the concept we are using in the network communication to make sure the source and destination are properly communicating to the right service. So as we said, maybe this server is using as a web server. It may be using a port number 80 and there is an FTP server running, and the FTP is running on port number 23, and maybe the server is working as an SMTP. So SMTP is running on port number 25 and our sales application is running on port number 443. So when the client sending the sale order, it decide the destination as port number 443. And who is deciding that the destination is 443? It is decided by the application itself. So the application developer configured the application to communicate with the port number 443 at the destination. So this is how each service is separated from each other with the help of a port number. So in the case of client machine, the condition is same. Maybe the client machine is doing multitasking. Maybe the Amazon.com is open in a web browser in the client machine to purchase something. Or maybe the cashier is playing an online game. Or maybe he is watching a movie through the internet. So all of these processes are separated by a specific port number, and source and destination will communicate based on that source and destination port number, and the communication happen properly. So here let's imagine the client machine is sending a data to the server, and in the data itself there is written it is going to the destination port 443, which is the specific port for the sales application in the server. And this communication also include the source port used by the client, and here we say it is port number 5000. So when the server receives this data, it can understand this data is coming from the source port 5000 and it is going to the destination port 443 inside me, and that is the sales application. And when the server responds to this query, it sends the data back to the client along with the information, the destination port 5000, because it's received the query from the port number 5000. That is the session from that client machine. So the response should go to the exact that port number. And the source port is 443. So when the client machine receive the data, it check the source port, okay, that is 443 and the destination is 5000. So it can understand this is the response I am getting for my previous query that I have sent to the server. So in this way, with the help of port number, each services are separated and communication is happening properly. So what is the port number? A port is a virtual point where the network connections start and end. Ports are software based and managed by a computer's operating system. Ports allow computers to easily differentiate between different kinds of traffic. There are 65,535 possible ports number, although not all are in common use. So that means in a network we can use 65,535 possible port for different purpose, but practically all of they are not using in the industry. Now what is the well-known ports? The port number from 0 to 1023 are reserved for common TCP/IP application and are called well-known ports. So in the network communication, there are some industry standard for the port number. There are some standard port using for some standard application commonly. They are showing in the picture. As you can see the port number and the service or protocol using that port number. As you can see the port number 20 and 21 is used by file transfer protocol FTP. Then port number 22 is using for SSH, 23 is using for Telnet, 25 is for SMTP, 53 is for DNS, 80 is for HTTP. Port 110 is for POP3, port 123 is for NTP, port 143 for IMAP, 161 is for SNMP, 443 for HTTPS. So these are the some commonly using well-known ports, and there are many ports available because they are starting from 0 to 1023, and here we mention only some important ports. So you can check in the internet, you can Google it and understand what are these well-known ports and that is using for which purpose. So that's for now. In this chapter, we have discussed about the transport layer and its functions in a network communication, and we also discussed about the multiple protocols used in transport layer. We have discussed about the TCP and UDP protocols. We have discussed about the port number, and finally we have discussed about the well-known ports. Thank you for watching. Please subscribe to the channel for more videos.